Let's start by thinking about the domain of this problem. Are there any restrictions on the values of x that we put into the function? Yeah, can't put in negatives. Can you put in 0? Can you take the log of 0? If you're not sure, what could you do? Try it. Put it in the calculator. It'll scream back at you domain error. All right, in which case you say, okay, I'll put a parenthesis around 0 as opposed to a bracket. So your domain is 0 to infinity. This is not a rational polynomial, at least not completely. So we're not going to get any vertical asymptotes because of a denominator equals 0 or something like that. We might get a little bit of something there from the minus log term, but it's not something that we're going to directly try and calculate. What else can we do? Well, we can look for, say, an x-intercept, a y-intercept. Those would be kind of tough. I'll let our calculator figure those out for us. Let's work with the calculus part of it and find some derivatives and see what the derivatives can tell us. So let's start with y prime. What's the first derivative going to be here? All right, 1/8 x squared. All right, because the 3 and the 24 are going to cancel. Minus 1 over x. Now for our convenience, maybe be better to write that as 1/8 x squared minus x to the negative first. Now, one way or another, we're going to need to play around with this and set it equal 0, etc. Let's see here. How do I want to do this? What I've suggested before is going to work now. Factor out that x to the negative exponent. So that's going to be x to the negative first. And what am I going to get when I factor out x to the negative first? What's going to be left? 1/8 x to what power? No longer squared. The third power. Because when you divide this out, you're dividing x squared by x to the negative first. You'll subtract those exponents, get x cubed minus 1. So overall, 1/8 x cubed minus 1 over x. So that's the form of our first derivative. Let's continue playing with that and figure out where it actually equals 0. Maybe, I don't know. What do you think? Is it going to be easier to work with if I maybe multiply both the numerator and denominator by 8? What would that give us? That would give me x cubed minus 8 over 8x. All right, that's a little bit more friendly. Easier to work with. I want to know two things here. I want to know where the signs can change in the numerator and where the signs can change in the denominator. So where can each of these equal 0? So denominator equals 0 and numerator equals 0. I got these backwards here, but that's all right. 8x squared, or 8x equals 0 when x equals 0. And the numerator equals 0 when x cubed minus 8 equals 0 or x equals 2. So I get those 2 points. Now one of those doesn't really help us out a whole lot, right? Which one? 0. Because 0 is not even in the domain, so I don't have to worry about 0. The function is not defined at 0 or to the left of 0. So 0 is not going to enter into the equation at all. Let's do our standard little table here. Got x, y, and y prime, and then 2 will be our point of interest. So I want to test 2. I want to test to the right of 2 and to the left of 2.
1 and 3.
All right, 1 and 3. Those would be good test points. So 1 and 3. You might want to plug that into your calculator to test it. It's kind of up to you. Let me help out in this particular case and just give you the answers. It's going to be negative and positive. So if it's negative, what's that saying about y? Decreasing. And then increasing. Now the derivative at 2 is 0, but the value of the function at 2 is not 0. And let's actually figure out what that is so that we can actually plot it. So that means plugging in x equals 2 into the function, and that would give me 1/3 minus the log of 2. So about negative 0.3, roughly speaking, maybe negative 0.36, I'm not sure. But that'll enable us to graph this. In fact, you know what, let's check that out. Let's 1 divided by 3 minus the natural log of 2. All right, not too bad of a guess there. Negative 0.36. It's about negative 0.36. Let's put that on our graph right now while we think of it. So this would be negative 1. So negative 0.36, about there. The function's not getting down too far, is it? Well, now that we've got the increasing, decreasing part taken care of, let's look at some other stuff. We need to figure out, say, the second derivative. Now, as far as calculating the second derivative, for myself, I think I might want to go back to this right here. You can calculate the second derivative using this form of the first derivative or this form. Which one do you want? The quotient or this one? That one. I kind of like that one because we're not going to have to use the quotient rule. We will have to factor a little bit when it's all said and done, but we won't have to use the quotient rule. So y prime is 1/8 x squared minus x to the negative first. Let's take a look at y double prime. There's going to be 2/4 or 2/8, which is 1/4 x plus, yep, x to the negative second. In terms of cleaning this one up, what should we factor out? X to the negative second. So I'll factor out x to the negative second. That's going to leave behind a 1/4. Now let me show the work here. So x to the negative second, 1/4 x to the negative second plus x to the negative second over x to the negative second. Yeah, so I'm going to have a 1 here. These exponents are going to subtract. 1 minus negative 2 is going to leave me with x cubed. Boy, isn't that going to be a friendly looking point. This cleans up as 1/4 x cubed plus 1 over x squared. And I think we're going to get saved in a nice, pleasant way here. I want to know where this can change signs. It can change signs where the numerator is 0 or where the denominator is 0. Well, the denominator equals 0 when x equals 0. And that's not part of the domain, right? So we can ignore where the denominator equals 0. But we still need to find where this can change signs. So x equals 0, that's 1 point, but like I said, it's outside our domain. There's nothing to the left of it, so we're going to throw that one out. This one gives us some more possibilities. So 1/4 x cubed minus or plus 1 equals 0. And I'm going to go a little ways to solving this one. You tell me when I can stop. I get 1/4 x cubed equals negative 1. X cubed equals negative 4. Can I stop? You can take the cube root of a negative number. Like the cube root of negative 8 would be negative 2. But there is a problem here. Can you see it? You don't have to calculate what the cube root of negative 4 is to see it. Yeah, it's not in the domain, right? It's negative. So this is another point that's not in the domain. Basically, what's happening is that the function, that is the second derivative, never changes sign for any value of x in the domain. It's always either positive or negative. In fact, if you did a little table, you could test any value that you wanted. Can anyone make a prediction as to the sign? So x, y, y double prime, any value at all. Yeah, I just choose x equal 1, right? If you choose x equal 1, the numerator is positive, the denominator is positive, the second derivative is positive. So Brandy, if the second derivative is positive, what's that telling me about the function? What's its shape? Concave up or concave down? That one. All right, that'd be concave up. All right, good. So it's concave up everywhere. And that's what you're picking up from this, is that it doesn't matter where you are in the function, it has a concave up shape. So concave up for everything on the domain, which would be 0 to infinity. Well, we've come up with this point. I gave you these 2 points just because I wanted you to be able to draw a nice graph. But look, you take out your graphing calculator. What's going to happen is that the graph is going to get closer and closer to the y-axis. It actually has a vertical asymptote at the y-axis, but it has a minimum point right there. Now, why do I know that this point has to be a minimum? Perfect, because of the first derivative test. It's decreasing, then it's increasing. So let's put this all together, draw ourselves a nice function, and then call it a night. So something like that. Any last thoughts on this one? David? No? Okay. Yes? Maybe. It's brewing. It's brewing. All right. Well, while you're working on that, let me assign some homework. Let's try 1 through 27. And let's see. 1 through 27 and 35 through 43. Did I not assign 4 or 5? 35.
Yeah, he wrote it down. I know it's 1 through 29. I think it's the last part. 35. Is it 35 through 37?
See ya!